Well, thank you for joining me on this questions to do with permutations and combinations. So I've got a question here on question 1. This is how many 3 or 4 digits can be formed using the digits, should be 3 or 4 digit numbers, I should say. How many 3 or 4 digit numbers can be formed using the digits 2, 3, 4, 7, and 8 without repetition? So let's look at 3 digit numbers first of all, and then 4 digit numbers, and add those two together. So how many 3 digit numbers and how many 4 digit numbers? So for 3 digit numbers, we've got 3 places. And so from 5 numbers, 1, 2, 3, 4, 5, and there's no repetitions there, we've got 5p3 permutations, different types of numbers. So there are 5 choices for the first position, 4 choices for the second, and 3 for the third. And that is 5p3, which is 5 factorial over 5 minus 3 factorial, which is 5 by 4 by 3 by 2 factorial over 2 factorial, and then we can cancel the 2 by 1, 2 by 1. 5 fours are 20 times 3 is 60. So there's 60 ways for this to happen. Let's look at 4 digits. Well, we've got 4 positions, and from 5 numbers, we want to have permutations 4 at a time. And this is, we've got 5 numbers for the first, 4 for the second, 3 for the third, and 2 for the fourth. Well, if you use factorials, this is 5 factorial over 5 minus 4 factorial. And so we've got 5 by 4 by 3 by 2 by 1 all over 1 factorial, which is 1. And that's just 1. 1 doesn't cancel, so it leaves it. So we got 20 times 6, 120 ways. We add those together, 60 plus 20 equals 180. That's the answer for part 1. There are 180 different 3 or 4 digit numbers. Let's look at question 2. Question 2 says a committee of 5 is to be chosen from 5 men and 7 women. How many ways is this possible if there must be more men than women? But anyway, let's see. This is the criteria, so let's go with it. 4 men. Well, we can't have a team of 5 out of 4 men. So we can have 4 men and 1 woman. That's one possibility. So how many ways can that happen? Or, so plus, we could have 3 men and 2 women. That's 5. And could we have 2 men and 3 women? Well, that makes 5, but we need more men than women. So these are the only 2 possibilities. So we can say that this is from 4 men, we want a combination of 4. And from 7 women, we want to choose 1. Now here, it is from 4 men, we want to choose combinations of 3. And from 7 women, we want to choose any 2, combination of 2. And this combination, with each of these men combinations, that's why we multiply. So 4C4, that's 4. Well, 4C4 is 1. You either know it's 1, or using factorial, it's 4 factorial over 4 minus 4 factorial, and 4 factorial. 7C1 is 7, or you know it's 7 factorial over 7 minus 1 factorial, and 7 take away 1 and 1 factorial. Well, we shouldn't need to do this. We should know that that is 1 without doing the math. And you should know, by the way, 0 factorial is 1. Be careful. Make sure you know that 0 factorial means no factors. There are no extra factors. It's just 4 factorial, 4 factorial. there are nothing here. That's a 1. So remember that 0 factorial equals 1. Don't forget that concept. 0 factorial equals 1. Remember that. 0 factorial equals 1. Don't forget that. So we've got 1 times, and 7 factorial, that's 7. You should know that straight up. Or 7 factorial over 6 factorial, and that's 7 times 6 factorial, so it's just 7. So we've got 7 ways here. Now, 4 factorial, 4c3 is the same as 4c1, so you should know it's just 4. Or 4 minus 3 factorial, and 3 factorial, and you're going to get 4. 7c2 is 7 factorial over 7 minus 2 factorial and 2 factorial. Or 7 factorial is 7 times 6 over 2 times 1. 2 places starting at 7, 7 times 6, and then underneath 2 factorial. And 2 goes into 6 3 times, so we get 21. Or if you do this, 7 factorial, 5 factorial, 2 factorial, which is 7 times 6 times 5 factorial, 5 factorial times 2 times 1. 5 factorials cancel, 2 cancels into 6 is 3, 7 3s are 21. So it's 21 times 4 is 84. So here we're going to get a total of 91 is the total number of ways that can happen. I hope this has helped. Until next time, stay happy.